So, welcome to another video on Digital Principle and Computer Organization lecture series. In this video, we are going to discuss about canonical and standard forms. That is canonical SOP or canonical POS, and it is also called as standard SOP or standard POS. These are the two fundamental forms for representing Boolean expressions. Here, the SOP, it expresses a logic function as sum of the product terms. Sum means R, product represent and. Whereas POX expresses it as product of sum. Here, SSOP, that is standard sum of product, which is a special form of SOP, where each product terms includes all variable of the function. So here it is a 3 variable one. So it consists of all the variables. It consists, if you take a product term, it has to, if it is a 3-bit means the product term should have all the 3 variables. It may be either complemented or uncomplemented form. CSOP is not a standard terms in digital electronics, right? But here CSOP represent this also, it is represent as a canonical sum of product. Okay. It is also known as disjunctive canonical form, DCF. So here you can see I have formed a truth table, right, which consists of inputs, right, X, Y and Z. Here the X is nothing but your MSP, and Y Z is nothing but your LSP. And I'm going to assign values to Z. Always LSP must be 1. Then that is 2 power 0. Anything power 0 is 1. Y is 2 power 1. And X is 2 power 2. So X value is 4, Y value is 2, and Z value is 1. So if I assign zeros and 1 to all those values, since it is 3-bit value, so 2 power 3 is 8, so it has to be from 0 to 7. So I can assign the values accordingly from 0 to 7. So 0 represents 0, 0, 0. X, Y, Z value is 0, 0, 0. Since Z value is 1, I am going to represent 1 as 0, 0, 1. Since Y value is 2, I am going to give Y as 1, and the rest of the values X and Z term is 0. To represent 3, Y plus Z, that is 2 plus 1 is 3, so 0, 1, 1. Next, X value is 4, so I am giving 1, 0, 0. Next, 4 plus 1, so X plus Z is 5. Next, X plus Y is 6. Next, X plus Y plus Z is 7. Okay. So if you see, if it is a 3-bit number, the minimum value of the 3-bit number is 0, and the maximum value of the 3-bit number is 7. So it ranges from 0 to 7. So if it is a min term, how to represent the min term? So the min term is you have to represent the variable in terms of product. Okay. So since the X value for 0, X, Y, Z value 0, 0, 0, right? So if it is 0 means you have to write it as X bar. Okay. So y also 0, so it has to be written as y bar. Z is 0, so it has to be written as z bar. Similarly, for 0, 0, 1, you have to write it as x bar, y bar, z. Next, for 0, 1, 0. For 0, 1, 0, you have to write it as x bar, y, z bar. Next, 0, 1, 1. So, x bar, y, z. Next, 1, 0, 0. So, x, y bar, z bar. Next, 1, 0, 1. 1, 0, 1 is x, y bar, z. Next, x, y, z bar. Next, x, y, z. So, I am going to give the minterm. We have to represent it as the designation. It is m, small m. Since the value is 0, so M0, M1, M2, M3, M4, M5, M6 and M7. Okay. Next, we go for max term. So, how to represent max term? The inverse of the min term is max term. Okay. Otherwise, you can write it as, so since it is a sum term, for since the x and y value, x, y, z value is 0, you have to write it as x plus y plus z. It should be in terms of sum term. Okay. So x, since x value is 0, you have to write it as x. Y value is 0, so you have to write it as x plus y. Z value is 0, so x plus y plus z. So this has to be, the designation must be capital M of 0. So similarly, if you see 0, 0, 1, you have to write it as x plus y plus z bar. So it has to be written as M1. So next for 2. For 2, that is 0, 1, 0. So we can see, I have already told you x bar, y, z bar. So how to x bar, y, z bar is min term. So if you take the inverse, if you want to take the inverse, first you have to apply the duality. So if I apply duality, it becomes x bar plus y plus z bar, right? This is your duality. Then you have to take a complement of each vector. So if I take the complement of each vectors, it becomes x plus y bar plus z. So I hope if I understood this one. Shall I go for the next thing? So consider the question they are given, f of 1. F of 1 is equal to x bar, y bar, z plus x, y bar, z bar plus x, y, z. So how to write in terms of min term? What is x bar, y bar, z? X bar, y bar, z is 0, 0, 1. What is 0, 0, 1? 0, 0, 1 is M1. Likewise, x, y bar, z bar. X, y bar, z bar is 1, 0, 0. 1, 0, 0 is nothing but 4. So you have to write it as M4. Likewise, x, y, z. X, y is nothing but 111. 111 is 7. So similarly, you can work out for F2. Okay. So if I want to take the complement of F1 bar. So what is F1 bar? F1 bar is, since I have represent M1 plus M4 plus M7. So the rest of the values are, it should be in terms of max terms. So what are the rest of the value? M0, capital M0 dot, why I am putting dot? It is, since it is a product term. M0 dot M2. Why I am leaving M1 is capital M1 is because it is there in the F1, right? So M0 dot M2 plus dot M3 dot M4. Small M4 I have let out, capital M4 I have let out because small M4 is there. So dot M5 dot M6. Okay. So how to represent capital M0? So to represent capital M0, you have to use x plus y plus z. Similarly, we have to do it for m2. m2 is x plus y bar plus z. Next, m3, that is x plus y plus z. Right? Sorry, x bar, it will become x bar, right? Mm, you will get x plus y bar plus z bar, right? So similarly, for 5, it is x bar plus y bar plus z bar. Next for 6, it is x bar plus y bar plus z. Okay.